Welcome to multiple choice question 22 of the 2009 Mathematical Methods Exam 2. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. And now before we move on, I'd just like to point out that the use of the CAS calculator is an efficient way to approach this question. So for question 22 we want to consider the region bounded by the x-axis, the y-axis, and the line with the equation y equals 3, and the curve with the equation y equals log e of x subtract 1. And we are asked that the exact value for the area of that region is equal to one of the following. So to start off with, we're going to sketch the region in this question. On the CAS calculator, go into the main menu. Now what we want to do is sketch the graphs, and firstly it is of log e, so we can use ln to represent log e on the calculator. So it's going to be log e of x subtract 1. And then the second graph that we want to sketch is just y equals 3. So clicking on the graph button, we can drag those graphs down one at a time. So that's the graph of log e of x subtract 1. And then this is the graph of y equals 3. And now what we want to do is we want to come up with a suitable view screen for those two functions. So it might be helpful to know where they intersect. So we can solve this is equal to 3 to do that. So interactive equation inequality solve for x, and it gives us x is about 21. I'm going to leave that exact value there as it's going to be useful in the future for us. And now for the graph screen, we could now set up our view as going between x is perhaps -1 and about 23. And for the y values, we could go between -1 and 4, and that would give us a fairly good view of what's going on. So there we can now see the setup, and we can start to identify the region where the area is located that we're interested in. And now just to find a few more key features, we can go analysis gsolve root, and for the log curve that happens at 2, 0. And if we go analysis gsolve intersection between the two, then that occurs at 21.086, which is e cubed plus 1, and the y value is of course 3. So from the calculator, we know that the function with the rule y equals log e of x subtract 1 looks like this. And the function reaches the line y equals 3, so that point there is 3, at an x value of e to the power of 3 plus 1. And we know that this point here is 2, and we're actually going to separate out our areas into two regions. This region here is going to be an integral calculation that we can use our calculator to help calculate. And this second region, which is just here, we're going to just treat as being a rectangle. So that means that the area of the region is simply equal to the sum of those two areas. So the first area, if we do the blue area, that's the integral between 2 and the value e cubed plus 1. And this is going to be a function where we do an upper subtract lower. So the rule for the upper curve, or that straight line, is simply y equals 3. And then we subtract away from that the lower curve, which has a function with rule log e of x subtract 1. And we integrate that with respect to x. And then we would need to add on to that the area of the green rectangle, which has a width of 2 and a height of 3. So 2 times 3 will give the area of that region. So on the calculator, we can now calculate this area. So bringing up the keyboard, we can go to Math 2 and find the integral symbol. And then we wanted to go between 2 and e to the power of 3 plus 1 as the exact value for the rule that was the upper curve 3 minus the lower curve, which is log e of x subtract 1 dx. And then we can also add on to that the calculation for the area of the rectangle, which is 2 times 3. So hitting execute, this doesn't appear as one of our options, but clicking the simplify button does reveal an answer that's available. So from the calculator, we found that that is simply equal to e to the power of 3 plus 2 when simplified. So that means that D is the correct answer for this question. So from the examiner's report, we can see that 45% of students got the correct answer to this question, so it wasn't overly well done in this exam. And the examiner's report gives the hint that the area could also have been calculated by going between 0 and 3 for a function e to the power of x plus 1 with respect to x, giving the same value of e to the power of 3 plus 2. So that method there relies on knowledge of the inverse function. So if this was our original function where we had y equals log e of x subtract 1, and that's the shaded area or region that we wanted to calculate, then the inverse, if we swap x and y and solve for y, the new rule could be written as y equals e to the power of x plus 1. And now the area calculation is slightly different. So for the first one, we saw that on the previous slide. And for our inverse function, that is simply 0 to 3, so the lower bound and upper bound of the x values that we're integrating between. For e to the power of x plus 1, that's the inverse's rule with respect to x, and you could check on the calculator that you'd get the same value out if you did that calculation. So that's a slightly different way to approach this question.